Good evening all. So good evening to all. Yesterday we were discussing about error analysis. So if you have any doubt, please let me know so that we can discuss about all the doubts related to error analysis. Yeah, please somebody tell me. Okay. Good evening, Priya. Yeah, do you have any doubt? Yes, just tell me. Okay, so yesterday we were discussing error analysis, and I have provided to you few examples. So I am going to take one example from yesterday class itself. Now we have yesterday class. In yesterday class we had a doubt. Suppose we have some I here, let this is some I, and another current source in this direction I1, and one more current source in opposite direction, let is I2. Okay, so now everyone, yeah, so today we will discuss ALCA, PMMC and moving iron instrument. And we will try to cover all the properties related to PMMC and moving iron instrument. So we will discuss all those things, but before that, yeah, so Prakshit, hi. So before discussing PMMC and moving iron instrument, we would like to discuss something about error. If you have any doubt, please let me know so that we can discuss it. Okay. Yeah, so somebody have any doubt? Okay, so how is SRM Chennai for the MTech? So yeah, Prakshit, it is nice institute, but I think you should think about IIT also. Okay, so which type of question will ask on CRO Gate E? Sai Kumar, from CRO they can ask designing of CRO, like which type material, or what is the working of deflection plate, horizontal plates, and what is Lessage's pattern, what about frequency response. So all those type of question they can ask from CRO. Okay, yeah, any other yesterday question answer? Yeah, do you have any doubt, Manish, so that we can discuss? Okay, hi Shiv Krishna. Okay, yeah, homework Manish I am getting, so tell me, do you have any doubt in any question so that we can discuss over it? Okay, so now see here, we were discussing this example. Let us assume, suppose I is given some value, okay, or whatever I1, I2 are given. So I am going to write or mention here, let I2 is equal to some I2 plus minus del I2, okay, del I2, and this I1 is I1 plus minus del I1. It is clear to everyone? Now dear friend, okay Manish, we will discuss all these things. Yeah, Dilip, hi. So please try to understand all those things. First, whenever we want to solve question or problems related to error analysis, we should take care about whether that given function is addition, subtraction, multiplication, division or power terms. If the problem is related to addition or subtraction, then we should add absolute error first. Okay, if that problem related to division, multiplication or power terms, then we have to consider relative error, as I told you. For example, suppose here we have absolute error, that one is also absolute error. For example, I am going to take one simple question. Let us assume, dear, this I1 and I2 are the resultant of I. So I is nothing but either I1 minus I2 or I2 minus I1, whatever. So I'm going to write this I is equal to, because incoming, so by KCL we can write I plus I2 is equals to some I1. So what will be the value of I is nothing but I1 minus I2. So I'm going to write in that fashion. Suppose I1 is 5 plus minus, just roughly idea, 5 plus minus 0.2, okay. So I1, I am going to write 5 plus minus 0.2 ampere. This is the tolerance limit. And I2 roughly we are taking 3 plus minus suppose 0.3 ampere. So these are the two quantity whatever we are assuming here. Now what will be the I? I is nothing but I1 minus I2. So we can write 5 plus minus 0.2 and 3 plus minus 0.3. And now we require subtraction. So 5 minus 3 is 2 and plus minus. We have to add that error. So that error is nothing but 0.5. Why we are adding that error? Because that error is absolute error, not relative error. Please mind it. That error is absolute error, not relative. So that's why we can directly add. So please try to understand, in addition, subtraction, we have to add error. Whereas in multiplication, division or power terms, we have to add relative error. Okay. Yeah, this is the thing. So now, before discussing about PMMC and moving iron instrument, again, I am inviting to you for any doubt from error analysis. If you have, please let me know, or just tell me in which type of example you are facing some problem so that we can discuss about those problems. Okay. So now, dear friend, we are going to discuss new topic PMMC. Okay. Just wait a moment. Yeah. So we are going to discuss here about PMMC. Now, first everyone be serious and tell me, PMMC is suitable for the measurement of AC values or DC values? Yes, everyone. PMMC is suitable for. Yeah, everyone listen to me carefully. PMMC is suitable for the measurement of DC quantity or AC quantity. And why that device is suitable to measure DC? You can also tell me. Okay, so Mayank replied, it is DC value. Dear friend, listen to me carefully. Yeah, DC everyone. Good job. So DC only. Now see, to design PMMC, we require two permanent magnet, and in between two permanent magnet, we placed one moving coil. We will discuss concept of moving coil sometime later. What think about permanent magnet? If we provide AC supply to permanent magnet, then resultant torque, then resultant power, whatever, will always be 0. So please try to understand, PMMC always provide, listen to me carefully, for gate point of view, PMMC provide average value of AC signal 0. I repeat, average value of AC signal 0. So that's why it is not suitable to measure AC quantity. One most important thing about PMMC, if we apply AC signal to PMMC, then it will fluctuate. That means meter pointer will fluctuate because of instantaneous torque. Dear friend, please mind it, because of instantaneous torque. So there is a lot of difference in between average torque and instantaneous torque. So when we provide AC signal to PMMC, it will show some fluctuation, but average wise its reading will be 0. For example, at starting our pointer is at 0 location. Due to positive AC signal, it will move up to suppose X point. Then due to negative, it will again return to previous point. So our final reading will be 0, but instantaneous reading will not be 0. Just keep in mind. Yeah, please mind it, dear friend. Listen to me carefully. Here we are going to discuss all those concepts to improve marks in GATE exam. Just listen to me carefully. PMMC can read 0 Hz signal or non-0 Hz signal also. Please somebody reply. Do it fast. PMMC can read 0 Hz signal or not equal to 0 Hz signal also. Can read by, yeah, Nikhil, thank you. So, sir, can PMMC measure non-sinusoidal wave AC signal? Yes, Anupam, please listen to me everyone. PMMC can measure non-sinusoidal wave signal also, but most important thing, the average area of that signal should not be 0. If that area is 0, our pointer will indicate 0 value. Yes, 0 hertz, Sai Kumar 0 hertz, Priya 0 hertz, everyone replying 0 hertz. So try to understand the concept here. PMC reads, yeah, engineer Mahesh is saying PMMC only reads DC and 0 hertz frequency. That is the most important point, my dear friend. PMMC does not read only signals related to 0 hertz. It can also read signal related to non-0 hertz also. Please mind it. Non-0 hertz also. For example, here, suppose, my dear friend, we have taken one half wave rectifier, and let us assume here our supply is, dear friend, 100 pi sine omega t, where this frequency is 50 hertz of supply frequency. Now, what will be the output here? Suppose we are using one PMMC emitter. Please mind it, PMMC emitter, and this is our R. So here we have, suppose, some V0 and function is I0. Now my question is, what will be the reading of this I0 if this R value is 10 ohm? Okay. Yeah, please somebody, please reply me. So yes, Manish replied 0 hertz. Everyone are replying 0 hertz. Just listen to me carefully. Yes. So now, dear friend, if I0 we want to calculate, and here PMMC emitter is connected, it means we know that PMMC reads only DC value. Please keep in mind and try to understand my like sentences, my words, what I want to say. Try to understand. PMMC emitter reads average value. They never said that signal, whatever we are going to apply across PMMC, that signal will be a 0 hertz. Please try to understand. That type of property is never defined for PMMC. So see here, somebody replied me Anupam 5 ampere. Let us see. What will be the V0 average in half wave rectifier? Everyone knows it. V0 average is Vm by pi, and is nothing but, dear friend, 100 pi by pi. So is 100 volt. So what will be the I0 DC? I0 DC will be V0 DC by R is nothing but 10 ampere. Try to understand the all concept, whatever here we are going to discuss. Yeah, Sai replied 10, Saurabh replied 10. Please match your answer. Now, dear friend, if we want to plot V0 waveform, then V0 waveform will be something like this. And try to understand, the frequency of this signal is not 0 hertz. Please mind it, the frequency of this signal is not 0 hertz. So PMMC, yeah, Mahesh, that is the most important thing. The output signal, whatever is going to appear across PMMC, that frequency is not 0 hertz at all. And you are replying, sir, it will read some value. How can PMMC read that value if frequency is not 0 hertz? You replied, na, PMMC works only at 0 hertz. That is absolutely wrong, dear friend. That is absolutely wrong. Okay. So please try to understand. In gate, keep patience, 100% concentration. Think about the problem, what they want to ask. Reply according to their questions. Please try to understand. Yeah. So, okay. Mathematics for JE. Okay, thank you. So Sai Kumar, if AC with low frequency, then pointer will slowly moves. Is right, sir? Yeah, definitely. Please try to understand. Again, I am going to repeat. If we apply AC across the PMMC, our pointer will deflect. But final result, that means in steady state, pointer will not deflect and it will show 0. It will show 0. That's why we are supposed to say PMMC definitely read AC quantities but not average wise. It will read, or it can show you only instantaneous points or instantaneous values, because when we apply any signal to the permanent magnet, then current will flow flux will develop, and due to this flux, one force, our coil will experience a force, and due to this force, our pointer will deflect, dear friend. So try to understand, there is a lot of difference. So here you need to try to understand the basics of PMMC. Just keep in mind. So my dear friend, here the output voltage signal is not 0 Hertz. Current is not at all 0 Hertz. So definitely PMMC will read average value, which is obviously not equal to 0, and frequency also not equal to 0. That is the thing. Okay, so thank you everyone. Now, any other doubt related to PMMC? Okay, now my next question, listen to me carefully. We know that, my dear friend, for PMMC, when we placed one moving coil in between two permanent magnet, and when this moving coil is connected across some supply, due to that supply, our coil will get energized. Due to energization of coil will experience some force. If coil will experience some force, then definitely coil has some, or coil will feel some torque. Due to that torque, pointer will move. Let us assume from 0 value to some value. Now my question is, what will be the wait a moment, what will be the angle theta, whatever we use in force is equal to this one sin theta. What should be the value of theta in PMMC? Yeah, somebody tell me. Okay, wait a moment. I'm not capable to read your replies. So just think about this problem. F is equal to BINA into sin theta. What should be the value of theta for more or high accuracy? Yeah, somebody tell me. Yeah, I repeat my question. Dear, listen to me carefully. In PMMC, we have one force equation. That force equation is nothing but BINA into sin theta. Now my question, what should be the value of theta for minimum error or high accuracy? Okay, so everyone replying that angle should be 90 degree. Okay, now dear friend, my question is not that one. Now my question, how can we make that theta is equal to 90 degree? What is the main instrument or device or material which is going to make our theta is equal to 90 degree? Yes, somebody reply me. What is the main thing behind to making the angle theta 90 degree? Yes, everyone please. How can we make this theta equals to 90 degree? Yeah, it is absolutely right. Okay, Wheatstone bridge resistance calculation. Sai Kumar, we will discuss. Okay, I'm getting your question. We will discuss like in tomorrow class, definitely. Yes, scale span should be 90 degree. Yes, everyone please reply fast. Okay, listen to me carefully, dear friend. If we are going to make theta is not equals to 90 degree, our PMMC will introduce high error. PMMC is nothing but kind of galvanometer. Please mind it, kind of galvanometer. And galvanometer provides a full deflection when theta is 90 degree. And to make theta equals to 90 degree, we require radial flux lines. Please mind it. We require radial flux lines. Okay. That is the most important thing. Now, dear student, radial flux lines we can achieve by soft iron piece. Angle made by needle to tangent at any point on the galvanometer box. Okay, so Akash, that is not, I think, sufficient explanation. Please try to understand and listen to me carefully. When we mount our moving coil on the soft iron piece, that soft iron piece can easily magnetize or demagnetize. Due to that property, we can make our flux lines radial. Due to these radial flux lines, our theta is 90 degree. It is very, very important point regarding PMMC. Just keep in mind. Okay, can you please highlight the properties of PMMC point wise that will be beneficial for the notes? Okay, so yeah, definitely Deepak, okay. Important. Yeah, Pradeep, DBM, CRO are definitely very, very important for our exam. Okay, so it is soft iron. Yeah, definitely it is soft iron piece. Please mind it. Now again, we will cover tomorrow. Just tell me which topic you want to like learn here. Just give me suggestion so that we can cover those topic in tomorrow class. Okay. Yeah, wait a moment. I have some doubt. We use an aluminium former. Yeah, please mind it. Aluminium former is not responsible for the theta 90 degree. I repeat, aluminium former is not responsible for the theta 90 degree. Okay, power tonic, CRO, eddy current, damping. Yeah, we will discuss all those things. Eddy current, damping, whatever. Now listen to me carefully again, everyone. Now my question is, in PMMC, we have one spring. And that spring will provide steady state deflection point. Steady state. Suppose, dear friend, we have one rope and we apply some force to rope in any direction. Then rope will also apply a force against our force. So that against force we can apply or we can provide by a spring. But main force we have to provide. Same thing we are going to use in PMMC also, dear friend. So in PMMC, when our coil, please mind it, when our coil, suppose this is our coil, when our coil is passing some current and will feel some force, so that coil will start to move, dear friend. If that coil will start to move, we require one spring, and that spring will apply opposite force and equal force also in steady state to our moving coil. That is the thing. So in steady state, we can write TD is equal to TC, where TD is nothing but deflecting torque and TC is controlling torque. TC controlling torque we can provide by spring, and deflecting torque we can provide by like moving coil plus supply. So in steady state we have this condition, and in steady state we also have BINA is equal to some K theta. So here we can write, dear friend, theta is directly proportional to I for the PMMC. Please mind it. Yeah, Deepak, we will discuss AC bridge with phasor also. Okay. Now, dear friend, my simple question is, we are using spring to get steady state position. Now, what will happen if suddenly spring broken due to any reason? If spring gets damaged, then tell me what will be the reading of PMMC. Everyone, please tell me what will be the reading of PMMC. Yeah, controlling torque is equal to damping torque to hold the needle. Definitely is right. Tell me where the iron piece used in the instrument through the diagram. Okay, Anupam, I will explain. Yeah, 0. Sir, please, where the iron piece? Yeah, I will explain, Anupam. Yes, any other question, beta? Now, try to understand when spring will get damaged. Please mind it. When spring get damaged, our PMMC will give 0 reading, dear friend. Our PMMC will give 0 reading. Now my another question is, listen to me carefully at every step. Another question is, PMMC has a linear, yeah, definitely Mahesh, PMMC has a linear scale. Now try to understand, if we are not going to connect spring to our PMMC, that means we are not providing spring anywhere in the PMMC with moving coil, then what will be the reading? Please somebody tell me. Then what will be the reading? Okay, so Shiva, we are going to discuss again all those things. Now, so you have question, if we are not going to connect a spring in PMMC, then what will be the reading? Now, dear friend, suppose a spring suddenly broken. So here we don't have any like that. This is our moving coil, and somewhere here we have a spring, where a spring is directly connected with moving coil. Directly connected with moving coil. Please try to understand. So now here, if our spring has been broken, then no current kind of will flow through the moving coil. Practically. Try to understand. So here reading will be 0. Yes, obviously, absolutely all of you are right. Please mind it. Now, beta ji, suppose we are not going to connect any spring in the PMMC. My question, what will be the reading? So yeah, Anupam, I'm going to discuss your question. Sir, please tell me where that iron piece is used. Okay. So see here, we have that one is aluminium frame, dear friend, aluminium frame, and we mount coil on aluminium frame. And inside the aluminium frame, here we have one soft iron piece. This is soft iron piece. Okay. So we mount our aluminium frame on soft iron piece. That is the location. 0 reading due to disconnecting spring. Yeah, definitely. All of you are right. Yes. Now tell me, please. If we are not going to connect a spring with PMMC, then what will be the reading? In that case, dear friend, our PMMC will read full value. Our PMMC will read full value if we are not going to connect any spring. In that case, PMMC will provide full scale deflection. Please mind it, everyone. Full scale deflection. That is the point. Okay. So 2 wattmeter method, very, very important, sir. Okay. Full scale. Yeah, definitely all of you are right. Now, this is last, but please try to understand. This is the last statement, but definitely again, it is very, very important. So please listen to me carefully, dear friend. And today I will try to cover wattmeter also. Okay. So just give fast responses so that we can discuss all doubt in minimum time. So dear friend, this is the last but very, very important thing. What is the deflecting torque equation? Is nothing but BINA sin theta, where theta is tends to 90 degree. Please mind it. Now we can write here, dear, in general, deflecting torque is proportional to I. Then what will be the sensitivity of galvanometer? What will be the sensitivity of PMMC meter? So sensitivity is nothing but 1 by IISc full scale, and unit wise, obviously it will be it will be, just wait a moment. Yeah, it will be ohm per volt. This is the unit. So sensitivity of PMMC is defined by 1 by IISc. Similarly, we can describe sensitivity of PMMC voltmeter. I repeat, similarly, we can describe sensitivity of PMMC voltmeter. In place of I, here, in place of I, we can replace this I by V by R. In that case, we can convert our PMMC ammeter into PMMC voltmeter. Please listen to me carefully. Okay. We are going to take our example related to PMMC, and please try to understand and solve it. Yeah. Full scale deflection sums also discuss. Full scale deflection sum. Dear friend Mahesh, okay, sorry, Manish, full scale deflection sum also discuss. Please mind it, if we have 2 to 3 meters with full scale value, then all full scale value we have to either add, subtract, or whatever purpose. That question will decide. I repeat, that question will decide. Whatever question somebody want to ask you. Can you please discuss sensors and transducer for IISc, because it is not GATE syllabus? Yeah, we will discuss, Deepak, all these things, but not here, because here we are dealing for GATE exam. Okay, but definitely after a month we will discuss all those things. Yes, yeah, definitely. Kulkarni, we will discuss transducer also. Okay, yes. So it is clear to everyone. Please reply for this question. So I read that example. A rectified type PMMC voltmeter has a sensitivity of 20 kilo ohm per volt. A reading of 4.5 volt is obtained when measuring a voltage source with an internal resistance of its 5 volt scale. When the scale is changed to 10 volt something and a reading of 6 volt obtained, the value of voltage and its internal resistance are. Yeah, please somebody tell me. Yes, we will discuss everyone, whatever topic you are providing to me. I will try to cover all these topics in tomorrow class, and some topics we will cover today only. Okay? Yes. So here we have some answer. So Kulkarni replied me, it is maybe C. Okay. Now, stop, I think, all this nonsense thing. Okay? Means no need to reply any option. Please mind it. First, try to understand what is the basic concept to handle PMMC type question, dear friend. PMMC type question. Now, to handle PMMC type question, like either ammeter or voltmeter, listen to me carefully, either ammeter or voltmeter. If your range, that means full scale deflection, is somewhat low value in comparison to whatever value we want to measure, in that case, you know very well, we know very well, PMMC ammeter require one shunt resistance and PMMC voltmeter requires some series resistance. All those things you have to keep in your mind. Now, most important thing again, dear friend, yeah, multiplying by factor of V by Vm. We will discuss, Mahesh. Now, listen to me carefully, everyone. Rectifier type voltmeter are very, very important or useful when we want to measure high frequency voltage. I repeat, when we want to measure high frequency voltage. If the frequency is high, we are not supposed to use PMMC, even not for 200 Hertz also. For that type of voltage measuring, we should use rectifier type instrument. Please mind it. Here somebody is using rectifier and output of that rectifier is going to provide our PMMC. So please, dear friend, try to understand, if we have here some full wave rectifier or a half wave rectifier, whatever, so I'm going to draw some equivalent circuit, that is our rectifier circuit or converter, and after that we are going to provide some supply some load. Let this load is roughly resistive, and here we are going to connect some voltmeter, or maybe here we can connect some ammeter. Dear friend, that is the most important thing, the location of voltmeter and ammeter. Now see, the output of this rectifier will be some V0, and that V0 may have some internal resistance, or that box may have some internal resistance, and that rectifier will excite by obviously some AC, that AC may be single phase or three phase. This is the first basic idea of that example. Please mind it, of this example. So now, dear friend, a rectifier type PMMC voltmeter has sensitivity of this. So first we have to mention is sensitivity. Sensitivity is equal to 1 by IISc is nothing but this 20 kilo ohm per volt. This is the thing. Now, a reading of 4.5 volt is obtained when, it is actually when, measuring a voltage source with an internal resistance on 5 volt. So we can say, dear friend, we have one voltage source, something like this, Vs, one internal resistance Rs, and somewhere here we have one voltmeter. And let us assume that voltmeter resistance is Rv and this is our Vb, voltmeter voltage. Try to understand. Okay. Now try to understand beta Rs and Rv and Vs. So by this thing we can write one equation, because our voltmeter is going to measure 4.5 in place of 5. It is clear? So what will be the by voltage division rule, what will be the voltage here? Just listen to me carefully. So by this circuit, this one, whatever, let this is a Vs, Rs, Rv, and this is Vv. So we can write Vb is equal to Vs into RV divided by RS plus RV. Now this is the important thing. Dear friend, try to understand all those things. First, we required the value of this RB because VB, voltage measured by potential coil or voltage measured by voltmeter, is already given and is nothing but how much? 4.5 volt. What will be the RV? RV we can calculate by sensitivity, dear friend. So what is the sensitivity is this one. So what will be the RV? Voltmeter resistance is nothing but 20 kilo ohm per volt into what is the reading of this voltmeter, and total voltage applies is 5. So is nothing but 5. So now it will be 100 kilo ohm. Volt and volt cancel. Please try to understand. This is the RV. Okay. So now dear friend, here now we have this value is 4.5 because it is measured value by voltmeter. Some drop due to internal resistance. So here 4.5 and this RV is 100 kilo ohm. Now we have two unknown. Unknowns are nothing but VS and RS. Rest values are known. So still we have two unknown and one equation. For second equation, dear friend, we can say 10 volt full scale deflection and measure 6 volt. Now due to this 10 volt, what will be the our RV? So due to that 10 volt, RV is nothing but 20. I think its sensitivity is how much? Yeah, 20. So it will be 20 kilo ohm per volt into 10. So that value is nothing but 200 kilo ohm. Now dear friend, it want to measure 6 volt. So we can write 6 is equal to Vs into RB divided by RB plus RS. And here our RB value is 200. So now by these two equations, let us assume it is second one. This is our first one. So with the help of these two equations, we can calculate Vs as well as RS. I hope that thing will be clear to you. If you have any doubt, please let me know fast. Yeah, everyone, please do it fast. Yes, dear friend, please speak up. Okay, so we are going to take next example, and next example is this one. Please read this example carefully and try to reply me. Okay, thank you, Janartham. Yeah. Please, everyone, reply it. Okay, so now read this question carefully and tell me the final value. What will be our final value or reading of voltmeter in volts? Yes, everyone. Okay, so Sibam, it is B. Yeah, maybe it is B. So just find out the correct answer by calculation only. Now see, listen to me carefully, everyone. Two resistors 4 kilo ohm, 250 kilo ohm are connected in series across 200 volt DC supply. Rest thing we will discuss sometime later. Okay, first try to understand the meaning of first line, first statement. So here we have two resistance, 1 and 2. First one is 400 kilo ohm and second one is 250 kilo ohm, and that combination is going to apply across 200 volt DC. Now it is clear to everyone. Now second thing, DC supply, a voltmeter full scale deflection 250 volt and its sensitivity 10 kilo ohm measures the voltage across 250 kilo ohm. Dear friend, here we require one voltmeter somewhere here, and that voltmeter will have some full scale deflection. So I'm going to write V of FSD, some sensitivity also. So we can assume it is some RV. I repeat, it is some RV. In that case, what will be the reading or actual reading of this voltmeter? We have to determine. Yeah, somebody replied me, it is 100 volt. Yes, everyone reply. Do it fast. because in gate we have like very precise time. We are not supposed to spend time in any other thing. So please try to understand, reply as much as like whatever soon possible. Okay, so 200 volt, 400 kilo ohm, 250 something. Dear friend, to calculate reading of this voltmeter, first we require this RV. And earlier I told you how can we calculate value of RV. So everyone replying Prakshit, Thiru, everyone you are replying 100 volt. So just see it. So dear, RV value is nothing but, what about sensitivity, 10 kilo ohm per volt. So 10 kilo ohm per volt into, what is the full scale deflection? 250. So dear friend, it is 2500 kilo ohm. It is 2500 kilo ohm. Okay, we will discuss, everyone. Just listen to me carefully. Here, now dear friend, previous example we can redraw in this form. So that resistance is 2500 kilo. This resistance is 250 kilo. That resistance is 400 kilo. And here we have supply 200 volt, I think. Okay, so just see here that supply is 200 volt, this one. Now my dear friend, we want to measure that voltage. Here some voltmeter is connected. So what will be the reading of voltage or V0 is nothing but 200 into parallel combination of both. So we can write here 250K, no need to write. So I'm writing directly here 2500, all values are K, divided by 400K plus 250 parallel with 2500K. Yeah, please somebody tell me what will be its final value. Okay, yes, anyone please tell me final value. Okay, good evening Vikash. Yes, so everyone please tell me. Do it fast dear friend, we have very limited time. So just tell me either it is 100 volt or any other value. Yes, everyone. Okay, so somebody replies me, Gokul, it is 72.463 volt. So I'm going to write your answer, Gokul, 72.463 volt. Okay, that is our final answer if we are not doing any calculative mistake. Please mind it. So now dear friend, like almost all of you replied 100 volts, but final answer is 83 whatever. Okay, 72 whatever, I'm not sure which answer is right. Just try to understand beta ji, our answer is not definitely 100 volt. That is the most important thing. In exam, that type of question we are not supposed to leave. We are not supposed to attempt wrongly, because that type of question are kind of rank improver type. So we can easily score good marks by that type of question, because luckily, okay, they will ask that type of problem. So please mind it, my dear friend, we are not supposed to do any silly mistake to attempt that type of questions. Okay, yeah, definitely Gokul and everyone, it is not equals to 100 volt. Okay, good evening Atul. Yes, so now we are going, if you have any doubt please let me know. We are going to take next example dear friend, and next example is this one. A periodic waveform observed across a load is represented by this and that. The measured value using moving iron voltmeter connected load is something. Yeah, anyone can reply you, please. So yes, Manish, it is, I think I'm going to tell you. So mostly I'm getting 72 point something. So I think answer in previous question, it is 72. Yeah, please somebody read this question carefully and tell to me what will be our exact answer. Yes, everyone. Need RMS value, somebody reply me. Okay, need RMS value. Now try to understand what is the main thing behind the moving iron. My dear friend, PMMC reads DC value. It is not capable to read AC value. Moving iron, listen to me carefully. Moving iron is capable to read AC as well as DC. But in laboratory, in practical life, we generally avoid DC measurement by moving iron instrument. I repeat, generally we avoid DC measurement by moving iron instrument. Why? There are a lot of reasons. Okay, we will discuss when we have sufficient time, but this time just keep in mind, if we want to measure DC value by moving iron, and if that value is very close to like 0 hertz, then in that situation error will be high. I repeat, error will be high. So that is the important thing. I have lot of answers also. Somebody reply me 67, 57 point something. Okay, just try to understand all those things. Here, dear friend, Vt is equal to 1050, 10 something and 5 this. And I'm not sure, okay, whether you are right or not, but please mind it, the calculation of this question is the most important part of the solution. Most important part, calculation. So I'm giving to you around 20 to 30 seconds. In this time or in that time interval, please try to find out the exact answer, whatever answer you will fill in the GATE exam. Just think over it, okay? Yes, so here that is our Vt or voltage supply. So dear friend, this is Vt. That voltage we are going to provide across moving iron instrument. Dear friend, first read the all frequency carefully. First frequency is omega, second frequency is 3 times something, and this fourth one signal has 5 omega, and last signal has also omega. Try to understand everyone. If frequency is same, then it will be arranged first. Yeah, that is the most important thing. Everyone listen to me carefully. First we have to arrange this second function and this last function. So I'm going to mark these function by different color. So first we have to arrange these two function. Yeah, please somebody reply me. What will be the beta ji? That values 50 and this 25 something. So I'm going to write here 50 root 2 with angle 30 degree, and another value is 25 root 2, 25, wait a moment, yeah, so 25 root 2 with angle 30 degree. Please somebody tell me, dear friend, what will be its value? Yeah, do it fast here, everyone. What will be its value? 50 root 2 angle 30 plus 25 root 2 angle 30 degree. Yes, so Nikhil replied me, it is under root 3300. Anyone other? With magnitude and angle, I need all these things. So after calculation of this value, dear friend, we can write here our Vt will be 10 plus some that component, and I'm going to leave some space for this like equation, and then 10 root 2 sine 3 omega t plus 45 degree, and last component we have this one 5 root 2 sine 5 omega t plus 25 degree. Please mind it, that is the important thing. Yes, somebody please reply me fast. What will be this value? So whatever this value will come, I'm going to write in this fashion: x sine omega t plus suppose some phi, and that x and phi we can calculate by addition of both. It is clear to everyone? Now dear friend, whatever that value is coming, just take RMS value of this function. So RMS value of that function we can write easily by that equation. So VRMS or reading of moving iron instrument, it is DC, so no need to divide by 2. Then second component x by root 2 square plus third component, dear friend, 10, and last one is 5. So here 10 root 2 by root 2 square plus 5 root 2 by root 2 square to power 1 by 2 is our final answer or reading of voltmeters, moving iron. So 91.855. Yeah, Atul, tell me that form in magnitude and angle terms. Yes, it is clear to everyone. Now listen to me, everyone. It is very, very important regarding moving iron instrument. Please mind it, regarding moving iron instrument. Listen to me carefully. It's a request. A moving iron instrument is very useful to measure AC values, but not for high frequency range. Please mind it, every word. Not for high frequency range. It is suitable to measure hardly 200-300 Hz up to only. Please mind it. Practically, it is suitable to measure hardly 400 Hz, 300 Hz up to. Not more than that. If we want to measure voltage or AC voltage for more than 400 Hz or 500 Hz, or maybe in terms of kilohertz, megahertz something, we should use either digital voltmeter or rectifier type voltmeters, not moving iron. First thing is this. Second thing, to extend the range of moving iron voltmeter or ammeter, we require similarly, like in PMMC, shunt resistance and shunt series resistance. But in moving iron, in general, we don't require simply shunt and series resistance. We require maybe shunt inductance, maybe shunt capacitance, or maybe combination. That thing we can finalize which combination will provide us minimum error. Dear friend, please mind it. Minimum error. For example, suppose we have one PMMC ammeter. Moving iron ammeter. Moving iron ammeter has the combination of series R and L. This series R and L will provide an impedance, and that impedance will finalize how much error we are getting when we want to extend the range of moving iron ammeter. So I would like to suggest to you here, just try to all those concepts by one example. For example, dear friend, we have one moving iron like ammeter in this fashion. This is R, that one is L, and here we have some V. Now suppose, dear friend, we require some shunt resistance to extend the range of moving iron ammeter. So that's why we have connected one resistance R here. Try to understand, dear friend. If we connect only resistance R across the moving iron, this is our moving iron instrument, across the moving iron, then R and the combination of RL will not provide equal distribution of current. In that case, we have large value of error. To minimize that error, to control that error, our shunt branch in moving iron instrument must have the combination of R and L. And we have to try to manage, please try to understand, dear. We have to try to manage here capacitive properties almost should be 0. Capacitive properties should almost will be 0. Please mind it. So due to that thing, here we are going to assume that is the impedance of meter, and this is the impedance of ZS. Here some current I, this is the I meter current. So we can write by current division rule, IM is equal to this I into opposite impedance ZS divided by sum of both. So by this thing we can calculate ZS, and whatever the value of ZS, please mind it that ZS or this ZSH whatever will always have series combination of R and L. If in GATE exam somebody asked to you, Sarji, if only resistive element is present or if only inductive element present, then like which type answer will come and what will be the percentage of error? In that case, dear friend, you have to calculate all the values at the same moment and compare those values with RL and without combination of RL. This difference or that analysis will guide to us to identify the error level in the measuring. Okay? So please try to understand these things. And next thing is, moving iron voltmeter. Please mind it, moving iron voltmeter. So moving iron voltmeter, let us assume here we connect some RS. This is our R and L. Okay dear. Now to calculate all those things, or to calculate voltmeter by moving iron, to calculate voltage by moving iron voltmeter, we require one shunt capacitor across it. In that case, we can measure AC voltage with high accuracy, or in other words, with low error. Please mind it, with low error. Dear friend, it is very, very important. I told you that moving iron instrument is not suitable for DC measurement, but still we are doing here. In comparison, if DC voltage and AC voltage are coming same, we can say that meter is going to provide us same error for both type signals, either AC or DC. But unfortunately, it is not going to happen. So to control all those things, please mind dear, we required one capacitor so that voltmeter can read all different values at all different frequencies. That voltmeter should be capable to read all voltage for different frequencies with minimum error. To take in that data, or to achieve our result with minimum error, we require one capacitor across the RS. And here we want to manage, dear friend, some time constant phenomena. Let this is LM, RM, whatever. This is CS or RSH and CHS. In that case, we have to maintain that shunt time constant is equal to meter time constant. And that shunt time constant is nothing but RSH into CSH is equal to RM into, or wait a moment, for RL, our time constant is LM by RM. If we maintain that criteria, we have minimum error. But not only by that criteria, we have to compare here DC signal as well as AC signal. Due to comparison, my dear friend, here some factor will introduce, and that factor is nothing but, please mind it, CSH is equal to, I'm going to write here LM and RSH, RM, whatever are equal. So I'm going to write some RS square or whatever, okay, in general form. And here we required 0.41. That is very, 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 very important relation to maintain our output with minimum error, so that our meter can read AC and DC, with high accuracy. Okay, that is the thing. So I think it is clear to all. So please follow these two properties whenever you want to measure voltage or current by moving iron voltmeter or ammeter. And this is the last thing about moving iron instrument, but definitely again it is very, very important. For PMMC we have developed torque BINA something, and for moving iron we have developed torque TD is equal to some I square by 2 DL by d theta, and in steady state that value is equal to K theta. So for moving iron instrument, our theta is proportional to I square, and due to this squaring terms, our moving iron instrument is capable to read AC values sometimes as well as for DC values also. Okay, so now on that behalf we are going to handle few more problem related to moving iron instrument. This is your problem. Please read this problem carefully, and if you have any doubt, let me know. Please do it fast. Yes, everyone. Yes, tell me everyone. Do you have any doubt? Okay. Yeah, frequency is okay, done. So this is our problem. Just read this problem carefully. A moving iron voltmeter reads correctly on 250 volt DC. So here that person is going to tell you one moving iron instrument, and that moving iron instrument provides very low error when it's read DC value 250 volt almost. Now if 50 hertz AC is applied to it, what will be the reading of voltmeter instrument or voltmeter? The instrument coil has 500 and 1 Henry something non-inductive, resistance is 2 kilo ohm. All those things are mentioned here. And also, with what value of capacitance must be the series resistance be shunted to make the meter read correctly at 50 hertz? This is also one more question. So read the question correctly and try to solve it and tell me the final answer. Yes. Everyone. Okay, so we will start tomorrow class by this example. Okay, so thank you everyone, and we will discuss tomorrow like a few examples of moving iron instrument, voltmeter, and few concepts of CRO also. Okay, thank you everyone.